We are going to look at section 3.3, and our first video is going to cover tautologies. A tautology is a logical statement which is necessarily and always true. And so whenever you're doing a truth table, what you're going to find is if it is a tautology, your last and final column, that last column is always going to be all true. Like every single statement is going to be true. So let's take a look at a couple of examples. So you have a couple of problems in your homework section which are going to look like this, and so the directions will say determine whether the given compound statement is a tautology. And so they'll give you a problem like this, and it will say P, like this one says P or Q, and Q implies not P. And so they want you to tell them, is this a tautology or not? And so what I've done is I've given you the truth tables for and, or, and the conditional implies, okay? So what we're going to do here is, this should be familiar to you by now. So we've done this now for a couple of sections. So we're going to go through this pretty quickly. So we're just going to list our P's and Q's. I'm going to go straight to my OR chart. So my OR chart is in purple here, and I'm just going to copy down my final column here. So there's my final column for the OR chart. Now, in order, so that takes care of this. In order to do this part, I'm going to need a not P. So I'm going to go ahead and just copy over not P. All right, so all I did was just copy over not P, so I just did the opposite of those. Now, in order to do Q implies not P, remember that I need these next to each other. So remember, I just have to have them next to each other. So I'm going to go ahead and bring those over. So I just have to have them next to each other. You may be able to just kind of look at them, but remember, I have to have them next to each other. So I write them small next to each other. So I brought my Q column over here. Now I'm ready to go over to my conditional chart, so my implies chart, and I'm going to go to T implies false, false implies false, T implies true, and false implies true. So I'm going to go over to that chart, and I'm going to copy all of those values down. So I did that. So I went and got all of those values down. So that's where all of those are. So that is this right here. Okay. So now I'm ready to do this final step, which the final step says P or Q, which that's my purple. That's this purple column. And then I'm going to do this yellow column and this. So I'm going to copy down my purple ones so that I have them next to each other. And then I'm going to use my AND chart. So I'm going to go T and F. So I'm going to come up here. T and F is false. T and T would be true. T and T is true. F and T is false. So all of those I'm going to go over, and there is from my AND chart. That's what that is. So I have finished my table. Okay, so here's my truth table. The question said determine whether the given compound statement is a tautology. So remember that the tautology, your final column has to be what? Has to be all true. So all of these would have to be T's in order for this to be a tautology. So the answer to this is no, this is not a tautology. Okay, so all of that to just say, no, it's not. So this is not a tautology. Okay, so let's look at another example. Okay, in this example, same directions determine whether the given compound statement is a tautology. But in this example, if you notice, we have a double arrow. So this double arrow is called a biconditional statement. So what this means is that you actually have to prove this statement in both directions. So you have to prove that P or Q implies Q or P, and then you have to turn around and prove Q or P implies P or Q. So the arrow has to be proven both directions. So this is called a biconditional statement. Okay, so it's really not that bad. So but anyway, let's see how this truth table works out. So quickly we'll do P's and Q's. The great thing is that P or Q, we can go straight to our OR chart. So there's our purple column. Now this says Q or P. So it is important that you put things in the right order. So now we're not P or Q here, we're Q or P. So you have to kind of flip-flop these. So again, my brain has to have them in the right order. So I'm going to write Q on the left and P on the right. So I'm going to rewrite it where Q is on the left, P is on the right. So I have to do that. So here's my Q's and then here's my P's. I just can't handle it. I have to rewrite it. So it only takes me a second to rewrite it. Okay. Then I'm going to go to my OR chart and I'm going to put all of those values in my OR chart. And when I do that and I put all of those in, then I get true, 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 false. Okay, so then now what I have to do is then I'm going to do my next one, which is I'm going to take the purple and implies this blue. Okay, so I'm going to write that. So now I'm going to do the purple and the blue. And so then I'm going to go over here and grab these values. So off of the yellow implies chart based on this. All right. So when I do that, I get all T's, which is good, except that remember we have to prove it going both ways. So now I have to prove it the other way, which is Q or P implies P or Q. Now, the great thing about this is Q or P implies P or Q. So that would be, if you just look at these red right here, if you look at the red ones, you're just going to, no, actually, you look at these right here, this purple, the purple and blue. So all you have to do is flip-flop them. Well, if you look at it, they're all the same. So it turns out that if you flip-flop them, they actually are the same things. So we are going to get the same exact values. Okay, so it worked out great this time. So actually we got all T's in both cases. And so is this a tautology? Yes. This is a tautology. So again, what is a tautology? A tautology is a statement that is always true. How do we know it's true? Because the final column in the truth table is always true. Okay, so it's just a fancy way of saying your last column is always true. All right, that's it for tautologies, and that's it for this video.